All right, it looks like we got a bunch of people that are starting to join. We're going to give you guys a couple minutes to let everybody get in and get settled. While we're waiting, if somebody could put a question in the chat just to make sure that you guys are able to ask questions throughout. There we go. Got a question from Larry. Thank you, Larry. We're doing good today. We're going to learn about the next generation of threat-informed defense, so it's a good day. If you guys want to put in the chat where you're tuning in from, let's see where everybody is. And we'll get started around 1:05. All right, we got some new people that are joining us. We're going to get started at about 1:05 to give everybody enough time to get in. All right, I think that we can get started and we'll probably have some more people join us shortly. But thank you everybody for joining us today. We're really excited to bring you this session on Next Gen Threat Informed Defense by Rajesh Sharma and Shravan Ravi. We also have Stephen Lincoln on the call to help answer any questions that you guys have. So if you have questions during the presentation, please put them in the chat or in the question box, and we'll go through them if we have some time at the end. So with that, I will hand it over to Rajesh.
Thank you, Liz. Can you hear me? Excellent. Welcome, everyone. Thanks for joining us. Today, we are going to discuss a topic I'm pretty sure you're hearing a ton about AI agents. They are all the rage nowadays. But we're going to discuss how these agents can help in threat-informed defense. So before we do that, who are we and why are we talking about this topic? I'll go first. My name is Rajesh. I'm the co-founder and chief architect at AttackIQ. People who don't know, it's a breach and attack simulation company. So it's in the name of the company. Threats are how we think all decisions should be informed. And not surprisingly, we also became one of the founding members for MITRE Ingenuity Center for Threat Informed Defense. Before AttackIQ, I wrote kernel device drivers in the network and storage tab for Windows, Macs, and Linux, mainly in digital forensics. On the personal note, I've been doing AttackIQ for close to 12 years now, and I recently turned 50, midlife crisis or what, and I love to go on hikes with my two boys, Shivan and Ahan, wherever I can. With me, I have my colleague, Shravan. Shravan, please go ahead and introduce yourself.
Thank you, Raj. Hello, everyone. My name is Shravan Ravi. I'm a security data scientist at AttackIQ, and I'm genuinely excited to be here today talking about this topic that I'm passionate about. I like diving into security challenges, and I love discovering patterns in both numbers as well as in music. On a side note, I have an identical twin, so if you're seeing double, you're not imagining things.
Thank you, Shravan. So what are we going to talk about? We're just going to briefly touch what is threat-informed defense. Then how can you assess how well you are already doing in using threat-informed defense? What challenges you might expect in its implementation? And how can you overcome these challenges with AI agents? What are these agents? How they work? And we'll illustrate the impact of these agents through an example case study. Then we'll wrap it up. Let's get started. So what is threat-informed defense? In the most simplest terms, it is know thy enemy and their game. It's about deeply understanding your adversaries' tools, technologies, and tradecraft, and then using that knowledge to inform your defenses. Imagine this: if you have a house in a decent neighborhood, would you still install a weapon-grade windows or a vault-style doors? So threat-informed defense focuses on the threats relevant to you based upon real-world observations, not just theory alone. What are we trying to do? We're trying to make the life of our enemy harder, making it difficult, time-consuming, and expensive for them to come after us. How we might do that? We might do that by forcing them to create new tools and technologies, find new vulnerabilities, find new attack paths in our environment. We're trying to slow down their OODA loop. None of this is controversial. People understand the benefit and they want to improve. But before you can improve on anything, you have to know where you currently stand. And knowing where you currently stand for threat-informed defense is not easy. This is where this MITRE's project called METED, I would like to invite you to check it out. It stands for Measure, Maximize, and Mature Your Threat-Informed Defense. So how did this project help you? The project website gives you a bunch of specific guidance and tools to self-assess your security teams. Using the tools from the website, you can quickly see how good a job are the three pillars of threat-informed defense are doing. For example, what you're looking on the screen is a result of a self-assessment by this fictitious company. They can quickly see how good a job is the cyber threat intelligence team or different functions within this team are doing, learning about the adversaries relevant to you and disseminating that knowledge across the different teams. They can also quickly see how good a job are the defense teams doing, the blue teams are doing, using this knowledge proactively to implement those findings. You can also find out very fast how good a job the testing and evaluation teams are doing validating those assumptions. Using the tools, you can see visually, right, where you're doing well or where you have gaps. And you can do that as an ongoing basis to track your progress. Now, why ongoing basis, you might ask? You know that well. Threat informed defense is a continuous process. The adversary doesn't stop. We can't stop either. It's a cat and mouse game in which both you as a defender and our adversary are learning and evolving. So for it to work, we have to keep with the changes. What kind of changes? Changes in your IT environment, changes in the threat landscape, and changes in the control capabilities, just to name a few. And usually, these changes are managed by different groups of people in your organization. And often the people who are managing these kinds of changes I just talked about are not open for changes themselves. Sometimes, in fact, they could be hostile to these changes. And that leads to silos. Silos break the flow of threat-informed defense, makes it harder for teams to collaborate and adapt. Why does these silos happen? Because our people, our teams start to become specialized, which is good, but also leads to problems, right? What is this? Why does this happen? You have heard about the saying about a specialist. Who's a specialist? Someone who knows more and more about less and less. And that leads to frustration. You can imagine the frustration of the defender who might be thinking, okay, you want me to defend you against this threat. You want me to put detection rules for this threat. But can I get some more context around this? After all, what's the point of you collecting all this threat intelligence if it's not getting to me in the way I want, when I want? You can also understand the frustration of the tester or a red teamer who might be saying, I ran all the simulation, find all the weaknesses in your environment, find all the attack paths to your critical assets. Now, what do I need to do around here to get some eyes on the findings I found? Now, can anything be done for these problems? This is where we think the recent shifts in the AI platform offer some promising solution. In a few moments, we'll share some of the agents we developed as part of this research. But what are these agents? Think of them as digital skilled workers who are capable of understanding their environment, make intelligent reasoning-based decisions, and take actions. Now, if you have to design these intelligent agents a year ago, it would be very difficult. However, now you got access to some solid AI foundations. You got access to some different large language models, which have unique domain-specific capabilities. You also got access to some solid techniques to compensate for weaknesses in these AI models too. For example, the problem of hallucination they cause, you all know about. All in all, these solid AI foundations are a blessing for anyone trying to design these intelligent agents. Now, these agents usually help you achieve a specific task. And they do that by providing a bunch of tools in the toolkits. And these agents often will invoke these tools using the intelligence capabilities of the LLM models. And these tools will often invoke some action in your environment using some sort of an integration. And this tool will use a technique called RAG, Retrieval Augmented Generation. For people who don't know, Retrieval Augmented Generation is a technique in which the tools will find the most relevant information in your data set about your question, then use that as a context to create an answer which is grounded in reality. Why is this important? Because in threat-informed defense, we have a lot of environment-specific data. You have your log files, you have your threat reports, you have your incident summaries. And you know that very well. If you have a question about your environment, you want to go ask that question to ChatGPT, it will just make it up. You need an agent of this sort to answer these class of questions. Now, how to design the intelligence of these agents. When you are designing the intelligence of the agents, you have a dilemma. On one side, you want to make your agents to be very, very reliable. But the more reliable you make them, they will resemble traditional code. They won't be very flexible anymore. But if you start chasing flexibility for your agents, they will go off the rails very fast. For people who, I don't know how many people here know, the projects like Auto GPT and Baby AGI, you know what I'm talking about. They're not very reliable. We think the solution is somewhere in the middle, where you have to constrain the cognitive flow of your agent. We use some a project called LangGraph from people at LangChain to strike a balance between reliability and flexibility. Now, a word about the deployment architecture behind these agents. Think about event-driven microservices. Your agents could be thought of as Lambda functions, which wake up whenever there's an output event on the event bus. What does this agent do when they wake up? They create tasks for themselves. Then they prioritize these tasks and even execute them if there is integration available. Human operators can also engage in the same activities. That is the activity of prioritization or executing them. At the end of the execution, the output will go back onto the event bus, waking up other agents. This is not rocket science. This is good old event-driven design, but makes our agents independent and reliable. Now, this is enough about the mechanics behind the agents. Let's see what these agents can actually do for us, how they can improve the flow of information between the teams. And let's do that through an example case study. Shravan, please walk us through that.
Thank you, Raj. All right, let's imagine this. MedSecure Inc. They're a mid-sized healthcare provider, just a regular day, nothing unusual, until it's not. Bam! Now suddenly they discover they're in the middle of a ransomware attack. The culprit, a group known as Blackbuster. Now, MedSecure CTI team is relatively less mature, which means they primarily rely on limited off-the-shelf reports. Sound familiar? It's like trying to fight a fire with a garden hose. Now, traditionally, this is what the workflow would look like. You've got teams working in their own silos with minimal overlap. Notice how this linear process not only eats up time, but more importantly, how each team's work is disconnected from the others. This is exactly what causes delays and incomplete responses against fast-moving threats like ransomware exploits. But what if we could work differently? Instead of a relay race, everyone's working at the same time in parallel with AI-driven agents speeding up each stage. Now, I know this diagram might look like a lot, but don't worry, we're going to break it down over the next few slides. For now, just think of it as a team where each team member is doing their part simultaneously, making MedSecure's response to Blackbuster much faster and more efficient. Let's see how this all comes together. Here's the first player in our team, the Threat-Informed Defense Advisor Agent. Think of this as the air traffic controller for your threat data, making sure everyone has the same view. Why does this matter? Without a TID Advisor Agent, Intel is fragmented, meaning each team is working off of different reports, leading to slow responses and potential blind spots. But with the TID Advisor Agent, we get one single source of truth and knowledge. MedSecure gets centralized intel and a shared understanding of adversary's tradecraft. No more silos. Once a TID advisor pulls in intel from a variety of data sources to minimize bias, it answers key questions instantly, such as who the threat actors, what impact they had, and what their motive could be. In this case, double extortion for financial gain. Let's bring this to life. What if you're the threat hunter at MedSecure? You must be wondering, I know I'm already under attack, but I wonder how far this attack has spread. Well, the TID Advisor Agent has just pulled in Yara and Snort rules directly from the threat reports. You can get to work immediately to investigate the scope of this attack across your systems. It's like having a head start, saving time, and making sure no one's left in the dark. Once teams share a common threat understanding, the next challenge is identifying exposure. Enter the ASM or Attack Surface Management Graph Agent, or ICE on the ground. It offers instant visibility by graph mapping vulnerabilities to assets and pinpointing risks quickly. Questions such as, do we have any public-facing servers affected by these CVEs? Get turned into actionable Cipher search queries in seconds, which gives MedSecure's teams clear insights into what's at risk. It's like moving from a paper map to a live GPS. The ASM graph agent, quickly spots the CVEs tied to Blackbuster as well as the technologies that this ransomware is targeting. Within seconds, it maps these to MedSecure's assets, pinpointing exposed servers and guiding the team on what to do next. With exposure mapped out, now it's time to test MedSecure's existing defenses against Blackbuster. Imagine you are a red teamer at MedSecure. You have been tasked with simulating a realistic attack scenario to emulate Blackbuster. Where do you begin? Here's where our attack simulation orchestrators come in. No more manual extraction of TTPs and creating scenarios from scratch. Instead, the assessment planning agent pulls in the most relevant TTPs and indicators of compromise from the report and uses this to build a robust simulation plan for you. Think of it as a master chef preparing the perfect recipe for your simulation. This makes sure that your simulation is realistic and up to date. Let's see how this works in practice. Ever wrestled with those tricky command lines and lol bins such as run DLL32 or vsadmin? Not fun, right? Well, this agent breaks down the tools and tactics used by the adversary Blackbuster, such as Mimikatz being used for credential scraping or rclone being used for data exfiltration, and it uses these automatically in the simulation. You can imagine what used to take days is now done within minutes. It also lets MedSecure's teams connect the dots using the MITA-ATT&CK framework. We can see here the full attack lifecycle from initial access all the way to final impact. Every step of the attack, from phishing to lateral movement to data exfiltration, is mapped using the MITA-ATT&CK framework. This gives our assessment planning agent the ability to automate scenarios and create simulations based on real-world tactics, giving MedSecure a clear view of how the attack unfolds. Remember, the faster we understand, the faster we defend. The next component of our simulation orchestrators is the scenario modeler agent. As you may know, building tailored attack simulations is challenging. Why? Because we often lack targeted custom scenarios for specific threats. That's why the scenario modeler agent comes in. It generates these scenarios on demand, specific to the threat actor MedSecure is concerned about. Let's look at an example. So in this case, Blackbuster makes use of a process injection technique, but perhaps we might not have the exact scenario the way it is used by Blackbuster in our simulation library. Here, you can simply ask the scenario modeler agent to create a Python scenario for you based on the specific techniques used by Blackbuster. And within seconds, you get a custom on-demand scenario, which you can then further package to use in your simulation platform of choice. Okay, you've run your simulation. Now what? You've got a mountain of results and you do not know where to begin. That's where the result gap analyzer agent comes in. It's like having a detective on your team, scanning through every result, pinpointing the weak spots. This agent, which is built on a SQL agent backbone, achieves this by translating natural language questions into SQL queries. By aligning the results with the MITA-ATT&CK framework, it tells you exactly which defenses struggled, which defenses failed, so that MedSecure's teams know where to double down. Finally, to turn analysis into action, we have the defense enhancement agents. Ever been in a situation where you're trying to fix a leaky faucet, but you don't know which tool to use? You're left guessing, which wastes precious time. Similarly, security teams face the challenge of picking the right defenses. They have to act fast, but vague mitigations slow them down. Enter the MITRE mitigations helper. It's like having a digital handyman who knows exactly which tool you need and hands it to you instantly. When faced with a threat, you can ask, what are the specific mitigations for T1055, for instance? And you get an instant actionable answer. No more guessing, no more lag, just swift, targeted defense measures. For instance, targeted MITRE mitigations can be obtained for T1055, a technique used commonly by Blackbuster. For instance, one of the mitigation recommendations here is implementing attack surface reduction or ASR rules on Windows machines. So what's more, you can ask the agent to provide step-by-step instructions on how to implement these ASR rules on any specific security control of your choice. In this case, Microsoft Defender for Endpoint that MedSecure is using. Finally, we have the Sigma rule helper agent. Here's one for all you detection engineers out there. You know the hardest part of writing Sigma rules? Getting started. Meet the Sigma rule helper agent, your new best friend. It's like having a rule writing assistant always on call. The agent creates a first draft of the rules for your needs, so you can quickly test or tweak it before deployment. Need a rule for DLL hijacking? The agent pulls the details and boom, your rule is ready. It's fast and it's tailored to your needs. Think of all the time you'll save. Now, instead of coding, MedSecure's detection engineers can focus on refining and deploying rules, making sure they detect threats effectively. What's more, the agent doesn't just stop at creating a Sigma rule. It converts it into a ready-to-use query for your security tools, whether it is Splunk or another tool that MedSecure uses. There you have it. MedSecure is now battle-ready for threats like Blackbuster. Silos gone. It's all about unity now. No more reacting. They're ahead of the game and proactively defending. These agents aren't here to replace humans. They're designed to augment your team's efforts, making sure they work faster and more efficient. That's intelligent defense. Fast, smart, effective, and collaborative. Back to you, Raj.
Thank you, Shravan. So hopefully you get the sense how these AI agents can help improve the flow of information from one team to another. It increases the chances of collaboration, how the output of one team more likely to be used by the other teams, reduces the chances of wastage. How these can help improve how we can run the OODA loop faster on the defense side. So threat informed defense is hard. And I sincerely believe that these agents that we developed, but I'm pretty sure what's going to come from the community too, is going to democratize threat informed defense. Because all of us are not in critical infrastructure, finance, or these elite industries. Everybody stands to benefit from the practice of threat informed defense. We have already open sourced some of these libraries we developed as part of the research, and we'll be sharing more of this work as time goes on with the community. Now, for all the developers on this call, if you are working on these agents, if some of these agents caught your attention, you need to compare notes, you have feedback, please feel free to connect with me, Shravan, or Stephen, or drop us a note at the end of the talk. But for all the other practitioners on the call, if you are a partner, AttackIQ customer, or maybe a prospect or someone who's trying to explore how we are thinking about integrating this technology into the AttackIQ platform, I invite you to check out AVA, AttackIQ Virtual Advisor. It's something which has been in early access for quite some time now. We've been working with some very few design partners to bring this technology out responsibly and reliably. Thank you so much for joining us. I'm going to hand this back to Liz. Take it away, Liz.
All right, so we do have a couple questions in the chat that we're just going to go over really quickly. So it was asked if any of these agents are available anywhere for download or use.
There have been a good question. Thank you, Liz. Currently, these agents are being available as part of AttackIQ Virtual Advisor. We are using behind the scene. But the technologies or the libraries like Sigma 1 is available at the link I mentioned. We'll be sharing more of this work for the community if they want to access it.
Perfect. And I did also put a link in the chat to the blog that is related to this topic. If anybody wants to go over and reread it or share it out, that link is going to be in the chat. And then another question I'm seeing is, what large language models are you using, and if they would be able to use it as well?
Good question. This is something we found out that this almost all of different large language models offer different type of capabilities, right? So we are using almost everything you guys are aware of. We're using models from OpenAI, 4.0, 3.5, different embedding models like text-3, small and large. We're also using from Sonnet, 3.5, version 1, version 2. And there is different, for different specific tasks, you pick different type of models. One thing I would say, especially for the case of threat reports, the techniques that we have to use is something called hybrid embedding. You cannot use like dense vectors alone. You have to use both sparse and dense because, as you all know, we have things called T1047, a technique. You have to make sure that this technique is exactly how it's found in your report, right? So there are some different techniques, different models being used, but we have to see what works best for different problem situations. Shaman, you can welcome to add anything if I missed something. Back to you, Liz.
Okay, I think that is all of the questions that we had. If you guys have any other additional questions, like they mentioned, feel free to email them, add them on LinkedIn. They would be more than happy to chat with you guys. And we thank you all for joining us today. Have a great day.
Thank you.
Thank you.
Thanks, guys.